Radio. Hi guys. Kia ora koutou. So this is a video explanation of rearranging algebraic formulae. So the other way you can think about it is rearranging equations. The other name for it is changing the subject of a formula. That whole formulae with the E on the end, that's plural. It's like saying formulas, but it's formulae because that's the plural. So we're going to start off, and I've already had someone saying that, in physics at the moment we're rearranging formula. Can you help us out with that? And that's awesome because we're doing that. Like, we're doing algebra at the moment, so it's great to jump ahead and look at this. And this is the main reason why we have to rearrange formula, is for real life sort of physicsy questions or chemistry or anything, economics, anything that uses equations, and you're wanting to find out things for different variables. Okay, so let's start off with a very commonly used formula, and that is the formula for converting Fahrenheit to Celsius. Okay, so if I had, I've got an old, say, recipe book, and it's got the temperature given to me in Fahrenheit, and I want to know on my oven that only does Celsius how many degrees to set my oven to, I could use this formula. And so, let's say that it told me to cook something at 350 degrees Fahrenheit. I can substitute 350 in here for F and solve that equation. Okay, so I'd get C equals 5/9 times 350 minus 32. Okay, so what though if it was the other way around? So let's say that you're at your great-grandmother's house. You know this recipe off by heart, and you know that you always set the oven to 180 degrees Celsius, but her old oven only has Fahrenheit on it. Or maybe you've gone to America for an exchange or something, and everything's Fahrenheit. You want to be able to convert things over. So in this case, you actually want an equation that's going to be F equals something, where you can plug in that 180 for C, you can substitute that in and get, some sort of temperature that's in the correct format in Fahrenheit for you. So let's have a wee look at this. So rearranging formula, we just have to, we just tread carefully. We just remember that whatever we do to an equation, we've got that equal sign in the middle, and that everything on either side has to be balanced. Okay, so you can think of those sort of scales, and that everything must stay balanced. You need the same thing. We'll make that one a little bit more horizontal. We need the same thing, on both sides, okay, to make them equal. So if we're going to do something to an equation, let's say we're going to add 5 on this side, we must add 5 on the other side. If we're going to take the square root of a side, we need to make sure we take the square root of the other side as well. So it's about being careful that you do the same thing to both sides. The other thing that we need to be really mindful of, so same thing, both sides. I'm getting used to a new computer here, guys. It's been a big learning curve this week. So same thing on both sides. The other thing is that we have to think about bed mass. And some of you, when you first started learning algebra, you may have learnt about the idea of a number machine and X going into some sort of machine that does stuff to it, and then you get stuff out the other end. So in this case, it would be that you had X, you added 5 to it, and then you times the whole thing by 2. And so you ended up with that coming out the other end of the machine. And so one way to think about it is that you need to undo things if you're trying to get X by itself, because in effect, that's what we're trying to do. If we look at the Celsius-Fahrenheit equation, we now want to get everything away from F so that we end up with F all by itself. Okay, that is in effect what you're doing. And so, with this idea with a number machine, you've done these things to X, you've added 5 to it, and then you've times it by 2. So when we undo it, we can think about it as we need to undo it in the correct order. Okay, so in this case, you'd have to undo the timesing by 2 part first, and then undo the adding 5. And we can tell that on here because the X plus 5 at the moment, he's all tangled up in these brackets here. And so we can't touch the X yet because he's all tucked up inside the brackets with the 5, that plus 5. And so we can actually, the first thing that we'd need to do is divide by 2. And that helps get rid of the brackets. And then we can start minusing 5. The other way to think about it is bedmess. Okay, so it is, you need to think about bedmess, brackets, exponents, dividing, multiplying, adding and subtracting. And that you're going to need to make sure that you remember bedmess and remember that you can't, I can't just go minusing 5 from that because I need to do brackets first, that way. So therefore I need to, when I'm going, I use bedmess the correct way around when I do something. So then when I'm undoing it, I'm actually going backwards. So you do your adding and subtracting first, then you're dividing and multiplying, and then exponents, and then brackets. So you kind of end up working backwards. It's like wrapping up a present and then unwrapping it. Okay, so when we're wanting to isolate some sort of variable, or get that variable by itself, we need to think about the fact that it's all wrapped up in a present. And like with pass the parcel, you have to start on the outside first and take all those outside things off to get back into the beginning. Okay, all right, so let's have a wee look at this wee guy here. At the moment, our f is all tangled up inside these brackets with the minus 32. So we need to undo this multiplying by 5/9 first. Okay, so there's two different ways that you can approach a question like this. You could think, okay, I could divide it by 5/9. I could divide both sides by 5/9, couldn't I? And then depending on how you feel about fractions, you might be like, sweet, that means I'm just actually going to multiply by the reciprocal by 9/5 because you know your fractions and how they work. Or you could instead treat this as two separate steps. You could have a look and go, oh, okay, I see. Actually, when I have a fraction times something, it means the whole thing is just being divided by the denominator here. So I could undo that dividing by 9 that's happening by timesing by 9. And this is what I suggest you do. It keeps things simple and it can also help get rid of fractions for you. Okay, so if we look at the first step that I would do here, we've got C equals 5/9 F minus 32. So this is the first thing that I want you to be able to do is if you've got a fraction being involved, in your equation and you need to, get rid of that somehow, multiply by the denominator, okay? And I think this is in your Walker Maths book. So multiply both sides by the denominator. So in this particular case, we're going to multiply both sides by 9. So we end up with 9c equals 5 times f minus 32. Okay, so we multiply by 9 on both sides. That managed to get rid of the divided by 9 on the right-hand side. And we've done the multiplying by 9 on the left-hand side to get 9c. All right, next step. Well, our f is still tangled up within brackets there, so we can't touch our f yet. So we're going to need to deal with this timesing by 5 that's going on. So let's divide both sides by 5. So here, I'll just put here, some people like to do this as well. We're going to times by 9 and times by 9. So now we're going to divide both sides by 5. Now, by the way, some people like to do this little arrow. You'll see this in mathematical situations. We can't say equals because then we'll end up with two equal signs written on the same line. We don't do that. That's really poor practice. Okay, we don't have two equal signs on the same line. We would write it one above the other. But you can put this little arrow like that. It's like an equal sign with an arrow on the end, which means this leads to, or the next step is going to be, that kind of thing. Okay, so that leads on to 9c divided by 5 equals f minus 32. Okay. All right. So brilliant. We've divided by 5 on both sides. What are we going to do now? We've got minus 32 happening. Okay. We've managed to get rid of those brackets because we've dealt with that multiplying by 5. So now we can add 32 to both sides. So let's do that. Okay, so that ends up with 9c over 5 plus 32 equals f. And here is your final answer. Okay, that's how you could convert it. So now I could put my 180 degrees in there, and I could do 9 times 180. over 5 plus 32, and that'll tell me how many degrees Fahrenheit 180 degrees Celsius is. And let's do it. I'm going to do it on my calculator now. 9 times 180 equals, divided by 5 equals, plus 32 equals 356. Okay, so 180 degrees Celsius equals 356 degrees Fahrenheit. Okay, so that is an example that deals with that dividing by a denominator situation. Okay, so if I find another little example for you here. All right, here's one here. Let's say I've got 5y equals 2 over x minus 3, and the instructions have been make x the subject of this equation. Okay, so this equation that we've got, that's explaining some relationship, isn't it, between x and y? And so now we want to go, okay, let's swap it around so that instead of saying y equals, or in this case it's 5y equals, let's make it x equals. All right, sweet. So again, we've got a dirty old fraction here. We do love our fractions, don't we? But let's make it not so fractiony looking. So as I mentioned before, we're going to multiply by the denominator. Okay, multiply both sides by that denominator, and then you're not dealing with fractions. So multiply both sides by x minus 3. Notice when I'm doing this, I've written the x minus 3 in brackets. So that denominator, it is x minus 3. I'm not going to times by x. I'm not going to just times by negative 3. Deal with it all at once, but I'm keeping it together because it's one thing, so I'm putting those brackets around it. So on our left-hand side, we'll end up with 5y times x minus 3. And on our right-hand side, we just got 2 left now, don't we? All right, so what are we going to do now? We want x by himself. At the moment, he's in brackets, tangled up with the negative 3. We need to get rid of that 5y that it's being multiplied by, don't we? All right, so let's do that. We're going to divide by 5y, divide by 5y, and we've got x minus 3 equals 2 over 5y. Does my x minus 3 need to be in brackets anymore? No, it doesn't, does it? So we end up with x minus 3 equals 2 over 5y. There we go. We're almost there. One last step. We've got x minus 3, so let's add 3 to both sides. 2 over 5y plus 3. That is our final answer. Okay. Looks pretty lovely. Yeah, it looks. So with this type of question as well, and you'll find this is what we get in algebra all the time, is that you can do things in a couple of different ways as well. So I'm just going to show you at that second step here, the 5x x minus 3 equals 2. If you wanted to, you might have thought, oh, I might expand out those brackets. Oops, sorry, it's not 5x, it's 5y. You might want to expand out those brackets. That's absolutely fine. Okay, if you had done that, you'd get 5yx minus 15y equals 2. You will have ended up, you'll add 15y to both sides. 5xy, you remember yx and xy are the same thing, aren't they? 15y plus 2. And then we would have divided by 5 and divided by x. Okay, so dividing by 5x on both sides to get rid of it. So we end up with, oh, sorry, we're trying to find x, aren't we? Not y. I'll just go back. So we divide by 5y on both sides. So we end up with x equals, because we're dividing by 5 and dividing by y, so may as well divide by 5y. So you'd end up with x equals 15y plus 2 over 5y. Okay, and then that, of course, could simplify down. 15y divided by 5y is just 3, and then we've got 2 over 5y as our other one. Okay, so they are exactly the same, just done in slightly different ways. Okay, so that's the first part of this, and then I'm going to start a second recording in a minute because I have a 15-minute limit on these videos.